He said, yeah. Marlon Londres. X minus 1, the x plus 1. Suppose the rational, and you put greater than or equal to 0. Solve it. Okay, nice. This is easy because some student, not me, or somebody, I don't know, create the right hand side 0. That's the most important part. And somebody, not me, do the factorization of the polynomial in the top and the polynomial in the bottom. You see the next example is no, it's no elementary. Okay, ready. And you compute the critical value. Critical value are the 0, but in this case you have 0, 2 polynomials, top and bottom. You take x minus 2 equals 0. Remember, critical value is when it's equal. Entonces the solution es obvio que es 2, 0 and 2. 0 and 2. And exactly the same we are doing in the polynomial in the bottom. And the solution is 1 and 81. Wow, we have 4 critical values. Okay, no problem. I understand. You are doing now the partition of the all real number line. Zero, critical. 2, critical. 1, critical. And 81, critical. Therefore, we have 4 partitions, we have 5 intervals. And you select in each interval 1 testing point. Okay, in my paper, I select -2. Here in the middle, -1 and 0, I select -1.5, I suppose. Let me make it zoom to see more clear. And between 0 and 1, I select +half. And between 1 and 2, 1.5 to 3/2 in fraction, either way. And after 2, 3, 4, 5, 5 testing. It's similar, except some detail different. You create the table or plug it in directly in the expression. It's up to you. Either way, keep it at 5. And -2 is -1/2 is +1/2, 3/2 and 3. Super. The factor involved in my problem is, look, I come back to the beginning, x minus 2, x minus 1, x plus 1, 4 factor, and the additional column is the total. You know that always we are doing. Okay, I'm plugging in. It's easy. This is the easy part. This is negative. This is negative. This is negative. This is negative. So you know, you one by one, you plugging in -2 here, 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 and here. In other words, you replace plugging in substitution x for -2, and you verify. I don't care the value. I care the sign. For negative, positive. Now likewise, negative. I do quickly, guys. See you see any discrepancy, let me know. 3 negative is negative. Half positive is plus. Minus, minus, minus. No plus here, plus. It's obvious. So 2 minus is positive. 3/2 is positive minus plus plus. Only one negative is negative. And 3 is positive. Everything is positive. See, everything is positive. It's so beautiful. And we come back again to the beginning. And you see our inequality is greater than or equal to 0. Okay, this is equivalent to say to be positive. That the true part, the true guy is the positive here. This is, let me see, let me use another color, maybe blue. This is true. This is true. And this is true. The negative, no, it's false. So this first testing point is okay. Negative 1, no. This 1/2 is okay. 3/2 is no. And 3 is okay. Okay, super. So now I highlight this interval. Don't forget that negative 2 is just testing point. And actually, our interval starts at negative 1. Okay, this is true, and this is true. Actually, we have in the solution 3 pieces. And the most complicated no, but a confusing part is the endpoint and the interval, included or not included. Well, our inequality actually is inequality and equation together. Therefore, si es polynomial inequality, we include it. However, this is no polynomial is rational. So include the 0 of the numerator. It's okay, because when the top is 0, the rational function is 0. However, when the denominator is 0, it's going to be undefined. So you include the 0 of the top only inside the solution. So in other words, this guy. And this guy, no. Was critical, it's okay. Was good, but no is inside the solution. Therefore, this is parenthesis here, and negative 1, and positive 1. And the rest is 0 is bracket, and then 2 is bracket. Where's the answer? The answer is, final answer. From negative infinity, comma, negative 1 parenthesis, union, the second piece is bracket, 0, because include 0, look at that, bam, comma 1, parenthesis, no include 1, because 1 is 0 of the denominator, union, bracket, 2, comma infinity. End the story. This is the final answer. Any question? It's similar. I suppose it's exactly the same of the polynomial, except that when the inequality is not a strict inequality. No, a strict is when you have that symbol or that symbol. No, include equal sign. So the 0 of the numerator is inside the solution, but the 0 on the denominator never. Clear? Yes. Super. So you have no question? So let's do one more example, and immediately we start doing the review step by step. At the beginning, we start for the first day. Polynomial, factorization. Okay, this is too long. Review, but it's okay. One more example. Example 2. Example 2, I want to complicate a little bit, not too much. It's 1 over x minus 2 less than or equal 2 over 3x minus 9. Wow. In this case, wow. Number one. We have no right-hand side 0. I need to create that. Number 2, I don't factorize anything. I need to do this algebraic work first of all. So no, the first thing you should do, so some people, I saw some tutor try to solve this like a cross multiplication. It's wrong, completely wrong. No, impossible. Now, suppose I write x minus 2 minus 2 over 3x minus 9 less than or equal 0. Wow, nice. Now, right hand side, now is 0. Good for me. However, this is completely different to another because I need to condensing this fraction and this fraction together in only one fraction. And two fractions is crazy. Nobody can understand this. So first of all, I see the factorization of the binomial in the bottom. No, in this case, it's impossible to do anything, but in this case, yes, the common factor is 3, x minus 2. And the least common denominator can help me to condense this is 3x minus 2, x minus 3. I take everything. They put a long line, they put the least common denominator here. Don't forget, let's down or equal to 0. And now let's find the top part. The top part is easy. When you divide mentally, the LCD, que is this guy, LCD divided by this denominator, they want to call denominator 1. It's obvious that this x minus 2 is cancelled with this. And stay alive 3 times x minus 3 multiplied by numerator 1. Okay, 1. Oof, nice. So 3 times x minus 3. Do you follow me? Minus. I don't finish. When you divide now, this LCD again, one more time, divided by denominator 2. I call denominator 2 because it's the second fraction. No? Es obvio que 3 is cancelled. And x minus 3 is cancelled. Now multiply by the corresponding numerator, que es numerator 2, que es negative 2 actually. Entonces 2 times x minus 2, something like that. Of course, I put this arrow to explain que this is cancelled when you are doing this, pero of course this stay alive. No? Everyone follow me in the elementary algebra? I finished, no? Yeah, okay, perfect. Now, I copied up. Of course, I apply this triple property. Multiply this and this, this and this. We have 3x minus 9, 3 times 3, no? Minus 2x plus 4, right? Almost we finish. Almost we finish. We combine like term. 3x minus 2 is 1x. Negative 9 and positive 4 and negative 5. Oh, nice. I like that. Wow, amazing. This inequality is equivalent 100% to this inequality. This inequality can nobody understand very well. Okay, we cannot apply cross multiplication. No cross multiplication. This is crazy. If you want to explain why, and this is easiest similar or a little bit similar to the inequality we solved in the example 1 today. No? But I have another question. Look. I can erase this 3 or no? What do you think? I can erase this 3 or no? What property I use to delete this? I can or I cannot? I can delete or no? I cannot. That 3. What do you think? No idea? No idea. Do you remember that I explained when you have a number, a positive number, we can delete? Remember, one more time, we understand that the important information in the inequality is the signs. And you know very well that the control of the sign is given by the negative factors. And the positive number is completely irrelevant. So you can delete these 3 and the solution for this inequality is exactly the same with 3 or without 3. Okay, so now If you see positive number, we can delete mentally. So you see negative, no. Well, you can delete if you switch in the inequality sign. Do you remember this explanation we did in the last class? Do you remember or you don't remember?
Yes, I remember.
Oh, exactly. Entonces now we use it. Suppose que I don't remember. Okay, when you are doing the table, you put one column que es 3. The column of the 3, the factor is 3. But 3 is always positive independent of the value of the testing point que I plug in. Entonces this is a stupid column, right? So these 3's go away. Now, the rest is piece okay. The rest is the critical value, x minus 5 equals 0 in the top, f5. X minus 2 in the bottom, f2. And x minus 3 in the bottom also, f3. This is our critical value. I'm using, as always, this critical value. I am doing the partition of the all real number. Now, this is 0, maybe. It's 1, 2, partition, 3, partition, 4, and 5, another partition. Okay, we have 3 partitions, we have 4 interval, and you select arbitrary testing point inside each interval. Suppose I select 1 or 0, or negative 1 or negative 2. I select here in the middle 2.5. I select here 4 maybe. I select 6, 7, 8, 9, either. The answer doesn't change. So you select 1 truly testing point inside each interval. Now ready to testing this point. This point you testing, plugging it directly in the entire expression. Oh no, I prefer doing it in a different way. I prefer doing testing in the factor by factor. Entonces es 1, 2.5, 4 and 6. Okay. And the factor involved in my problem are, doesn't matter, the order is not important. X minus 5, x minus 2, x minus 3, and 12. Okay, 1 is negative here, obviously. 1 is negative here, obviously, negative, 3 negative, negative. Remember, the total I enclosed in the circle because this is important information. The other partial. This is the same thing. You plug in directly here and you get, I don't know exactly, you get negative 20 because it's negative. 2.5 is negative. 2.5 here is positive. And 2.5 here is negative. And 2 negative is positive. 4 is negative. 4 is positive. 4 is positive. 1 negative is negative. And finally 6 is positive. Positive and positive. We go back at the beginning. The beginning of the inequality is less than or equal is equivalent to say to be negative. And the true guys are this and this. And the rest not. In conclusion, the testing point que passed the test was this guy. Good for you, for 1. 2.5, no. 4, yes. 6, no. Okay, so I highlight the corresponding interval, guess this interval, look. And this interval. Good, very good. And what about the endpoint? Well, the only endpoint is closed F5, because 5 is the 0 of the numerator. So now, the symbolic way to indicate this idea is bracket here, parenthesis, parenthesis. Where's my final answer then? My final answer then is answer from negative infinity, comma, to parenthesis, union, and the second piece is parenthesis, 3,5. Okay, cool. Do you understand very well everything? Any doubt, any question, any? Okay. Okay, okay. This is easy. I like that. This is super straightforward. Okay, so you have no problem. I propose you start review at the beginning. At the beginning, the review package I sent today together with the link in the Skype. Not necessarily you open now because you can see now on the whiteboard. So I prepared the whiteboard. I upload this package. Let me see where. There you go. That one. How many pages? Wow, too long. That is okay. Let's do it step by step. Don't rush. The thing is that you understand very well everything. I select the page 1, enlarge the page. Let me see, zoom in. Close that. Zoom in to see more clear. Question 1, question 1, question 1. Question 1 say, for the polynomial, listing each real zero and its multiplicity, determine whether the graph crosses or touches the x-axis. Remember, guys, let me put separately that part because I don't want to get confusing. Okay, now focusing down. The polynomial is, I want to copy again to see more clear. F of x. Wait. F of x is equal 1/3 x to the 4th power x squared minus 5. And they want to you find the 0. And you put equal to 0, okay, the x in a cell. I know, okay, x to the 4th power is equal to 0. In conclusion is x equals 0. But the problem is that the multiplicity is 4. Actually, the degree of this polynomial is 6. Where come from 6? 4 plus 2. Actually, the degree is the higher exponent, no? The monomial contains higher exponent. However, unfortunately, in this example, I don't know why it's expressed in factory form. You want to express it in expanded form, you apply distributed, no? And it's obvious when you multiply x to the 4th power and x to the 2nd power is to the 6th power. Degree 6. But actually, we have 6 0. But 4 are 0. So 1, 2, 3, and 4 0 because the multiplicity is 4. And we have another case, the other factor equals 0. This is equivalent to say x squared equals 5. Apply square root both sides. X alone is equal plus or minus square root 5. Actually, we have two more. Que es x equals 5, radical 5, sorry, and negative radical 5. By the way, the multiplicity of this guy is 1. So in total, we have radical 5 and negative radical 5. It doesn't matter the order is not important. So the 0 of this polynomial is 4 0 and positive radical 5 and negative radical 5. In total, we have 1, 2, 3, 4, 5, and 6, exactly the same of the degree. What touch and what cross it? Well, when the multiplicity is even number, it's touch. This is touch, x-axis. Because the multiplicity is 4, it's even number. And when there's odd number, like a 1, like a 3, like a 5, it doesn't cross. Okay? They don't want you do the graph of this. But see, I try to understand this. Look, the graph looks like roughly, of course. In behavior of this polynomial, in behavior, it's obvious que es 1/3 x to the 6th power. You apply the the distributive property here. And therefore, coefficient is positive and exponent even. I suppose que the end behavior look like that. O sea, es right up, left up. However, we have in 0, well, in radical 5, I suppose que this number. In negative radical 5, we have this. In 0, we have another 0. 3 0. This is multiplicity 4. So I suppose that this crossed, this touch, and this cross. Entonces the option que ahí select es the option, I don't know, si es B o C. No, es B. Es obvio que es B. Any question? B option. B option, no C. Do you understand very well or no? Come on, this is a review. This is a moment. Oh, yeah, I understand. Okay. It's a moment in the test. Sorry, I cannot help. Okay. No problem. I understand now. We move on to the second question. Second question is simple. The review repeat and repeat and repeat and repeat. But it's important repeat. Okay, you have a function, polynomial. The coefficient is 1/2 x to the 4th power, and we have x squared minus 5 x minus 2. Ooh. Again, this polynomial is expressed in factorial form. Somebody did a job to factorization this polynomial. Okay, no problem. Okay, now you put it equal to 0 because the problem say compute the 0 and classify multiplicity. Entonces now again we have x to the 4 equals 0. This is equivalent to say x equals 4 multiplicity 4. The factor x squared minus 5 equal to 0. This is a quadratic equation. Similar. We have x equal positive and minus radical 5. So now we have x equal radical 5 positive multiplicity 1 and negative radical 5 multiplicity 1. And finally, x minus 2 equals 0. Okay, it's equivalent x equal to multiplicity 1 again. In total, we have 7, no? 7, 0, because 4 plus 1 plus 1 plus 1 is 7. And it's perfectly corresponding with the end behavior. So the end behavior of this polynomial is 1/2 x to the 4th, x to the 2nd, and x. Because you consider 5 and to complete it negligible. Now this is 1/2 x to the 7th power. And yes, x to the 7th power, this is extra to understand a little bit, is the end behavior. This is the axis, the x-axis, the end behavior is like that. Like that, look, is right up, left down. Because the coefficient is positive. And also, the exponent is odd number. This is the end behavior. And in the middle of this end behavior, we have 0 here. Okay, by the way, 0 again touch the axis. However, in radical 5, okay, by the way, so you put in the calculator, radical 5 is 2 point something. Decimal approximation. Let me try. Square root 5 is 2.23 in decimal, to have some idea, because we have 2, 1, 2, 3, 2.23 here, 2 is another 0, and negative 2.3 is a negative 1, negative 2, negative 3, approximately here. So we have 1 0 here, cross, we have another 0 here, cross, we have another 0 here, touch, and we have another 0 here, cross. cross, touch, cross, and cross. Something like that. You want to verify this, you are doing decimals, and you'll see perfect. So now the option C is the correct answer. Multiplicity 4 touch, 2 multiplicity 1 cross it, radical 5 multiplicity 1 cross it, negative radical 5 multiplicity 1 cross it. Cool? Cool or not? Excellent, beautiful.
Yeah.
Okay, let me try now to open decimals because I want to see the graphic part. There you go. There you go. I don't know, we continue working in the whiteboard. I open. And my computer, no, I don't share the screen. Let me try to do number 3. Number 3 is do the graph. This is important, guys. Important. Do the graph of several rational functions. And remember the famous 7 step that we need to do the graph of this. Okay, I delete. My number 3 question says f of x is equal x minus 1 over x. Wow, I don't understand anything. It's not good for me. What is that? Not clear. No problem. I try. Look. I suppose it's better condensing this in only one fraction, because x is the LCD between x and nothing is 1, and we have x squared minus 1. Okay, this is equivalent. Oh, it's more clear now. When you are doing the degree analysis, the degree of the polynomial at the top is 2. And the degree of the polynomial at the bottom is 1. Okay, more clear now. However, I want to express it in factorial form. Like factorization, the top part, like a different of square, x plus 1, x minus 1, divided by x. And this is equivalent to the original. There are many ways to express it, like that, or like that, or like that. They are algebraically equivalent. Everything is the same. But I prefer that way, que es factorial form. And the factorial form is important because the factor que is the same in the top and the bottom, we can cancel out. But unfortunately or fortunately, I don't know, we have no common factor to cancel out. Because it's x plus 1, x minus 1, and x alone. So no whole. The conclusion is no whole. Good. No whole. The next step is compute the y-intercept. The y-intercept, the formula, remember, evaluate en 0. Bueno, evaluate en 0 is, en 0 is undefined. Undefined, because it's 0 in the denominator. That means that we have something weird here in the denominator. So no, undefined is nothing. Undefined is error. Therefore, y-intercept do not exist. Okay, no problem. Now, in order to find the x-intercept, you evaluate the function. No, evaluate no. You put enforce it to be 0, que es equivalent to say the polynomial p, que es the polynomial at the top, you put the 0. So actually, I take this guy. If I ignore temporary this x, I have x plus 1 times x minus 1 equals 0. Oh, nice. X equal negative 1 and x equal positive 1. And the point are negative 1, 0 and 1, 0. At least we have 2 points. Here, no point. No point. Undefined is do not exist. Do not exist what? The y-intercept. No, we have no. But we have 2. X-intercept. Nice. After that, well, the next step is the vertical asymptote. And the vertical asymptote, remember, is you take the polynomial, the denominator is this. Now I take this, and you enforce it to be 0. Oh, now I understand why we have no y-intercept. The reason is clear, because this function at x equals 0, we have a vertical asymptote. This is my famous real number line, positive infinity, negative infinity, but in 0 we have vertical asymptote, and the curve never touch. No. However, we have a -1 here, -1, 0, 1 x intercept, and 1, 0, we have another intercept. And the last step, if I want to compute something, I select testing point. Testing point, no, additional point, maybe in 2, maybe here in 1/2, in 3 or 4. The minimum is this 1 in this interval, 1 in this interval, and 1 in this interval. It would be maybe my -2 or -3 or -4. Okay, now let's analyze. The next step is the step of the horizontal. Let me use in black color. Horizontal. Okay, horizontal asymptote or slant. Remember, we have the two possibilities, and you need to differentiate is one or another, because both is still possible. They are mutually exclusive. If we have a slant, we have no horizontal. If we have the horizontal, no slant. In this case, you are doing the analysis of the degree. Actually, I did at the beginning. Look, when you have that situation, okay, the degree of the top is greater than 1, the degree of the bottom, you have a slant. You have a slant and no horizontal. Even the horizontal, we have only when the degree is the same or backward, so completely different. Degree of the denominator is greater than the degree of the numerator. In this case, completely different. Degree of the numerator is bigger than 1. See, it's bigger than 2? No. See, it's bigger than 1? Yes, it's slant. We have a slant. To find the slant, we are doing division. But actually, look, not do anything, because at the beginning, somebody separate this. And so my function is equivalent to this, pero es also equivalent to this, pero es also equivalent to that. Entonces es x minus 1 over x. And this is a slant. Look, that part is the slant. Y equal x. Then the slant is a line. It's oblique one line. And it's y equal mx plus b. In this case, b is 0 and m is 1. It's y equal x. Entonces, super easy to do the line, no, of the slant aspect. Okay. Now, finally, the symmetry. To testing the symmetry, you replace x for -x, and let's see what happens. In the original, in either, I suppose the original better. Is x, so f of x is x minus 1 over x, and you are now replace x for -x. So minus x minus 1 over minus x. This is minus x plus 1 over x. Wow, and when you compare this and this, is identical, except it's completely opposite side. This is a clear idea against odd function. If it's odd function, then you need to find only the positive part, so 1/2, 2, or 3, because the value that you get when you plug in this value, and another is completely opposite side. Okay, so not necessarily working with the positive part or the negative part, only positive part. I like so much. No? Okay, but unfortunately, we are doing decimals. Immediately I switch into decimals and we compare where the option is better, right? You say in decimals, look, I have that. Let me share the screen. Share the screen here and there. Okay. View, grid view. I don't like this view. Grid view is it correct? Decimals. Sorry. Decimals. Switching to decimals. There you go. Boom. Boom. Do you see decimals? Okay. Look, the question 3. No. Sophia is a no. Sophia don't see decimals. Everyone saw decimal or no? Only Sophia. Nobody see decimal. Let me see. I see. Sophia, maybe you have some delay. Don't delay. Yeah, I see. Okay. Sophia, you see now? Yes. Okay. Super good, Sophia. Okay, look at that. I saying the decimal script, and you open at home. It's that one. Bam! Look at that. The typical point is the x in a set, 1,0, negative 1,0. I plot in 2, I plot in half, and look, the value of the y is exactly the same because it's odd function. Look at the proof is odd function. You see now clear. 0.5, comma, negative 1.5. And negative 0.5, comma, positive 1.5. It's the same value, but opposite sign. So, in other words, when you change the sign of the x, the sign of the y is also different. It's opposite sign. The typical of the odd function. And we have the classical slang accident. Look at that. This is a slang accident. Do you see how our curve in the green and blue color approach but never touch? Never touch. In both directions, guys. And also we have the vertical accident at 0. Look at that. Okay, it's not clear because it's confusing with the y-axis. But it's okay. Entonces now, when I select the answer, we'll come back to the whiteboard. And I select the answer. We see the answer. With the answer in that paper. Okay. Let me enlarge. Wow, no good. Boom. Okay. Let me share the whiteboard. Whiteboard for you. Okay, good. Do you see whiteboard now? Okay, look at that. This is the continuation, the page number 2 and the review package. It's obvious. It's not obvious at all. Using your imagination and try to thinking about this is the option A, no? That one. Option A. Are you agree or disagree? Agree or disagree? Everyone is agree? It's option A. Do you follow me? Do you understand very well the thing I am doing? It's confusing, you don't remember, you remember? Let's practice more.
That's pretty clear, Professor.
Okay, super. This is my intention, no? My intention is help you. Okay, let's move on to page 2. On page 2 we have another. Okay, is I want to copy now in detail. Make it zoom to see more clear. Is question 4, no? We're doing number 4. F of x is equal x over x to the second power minus 15. Wow. See, I'm doing the analysis of the degree of the polynomial in the top is 1. And the degree of the polynomial in the bottom is 2. Okay. I don't know I'm doing that in that moment. I'm doing the corresponding moment of the slant asymptote or horizontal. Okay, according to the order, the first step is factorization. In this case, I saw in the bottom we have difference of a square root 16 and 4, positive and negative. Now, this is my new f of x. They are not common factor that we can cancel out, no whole. I like that. Okay, now just finding y-intercept. Evaluate 0. 0 divided by 0 plus 4 times 0 minus 4. It's obvious. Automatically you see 0 in the numerator is 0. And the point is 0,0, que es the origin. Que I suppose que es both x-intercept and y-intercept. But suppose que I don't know. I try x-intercept. What is the formula for finding x-intercept? F of x equals 0. Que es equivalent to say p of x equals 0. In other words, the polynomial in the top equals 0, and the polynomial in the top is x equals 0. And we conclude exactly the same, x equals 0, 0, 0. So we have only one intercept, que es a coincident x-intercept and y-intercept in the origin, 0, 0. End the story. Vertical asymptote. Easy. Vertical asymptote is you take the polynomial q, que q is the polynomial in the denominator, and you enforce it to be 0. We have to factor x plus 4 is equal to 0, x negative 4, and x minus 4 equal to 0 is positive. Okay, in this moment, I like so much doing the partition. We have all real number line, infinity, negative infinity. By detecting in 0 we have x-intercept. In positive 4, 1, 2, 3, 4, we have vertical asymptote, and negative 4, we have another vertical asymptote. So in the time I need to evaluate to include extra point, well, I select maybe 0, no, because 0 I did that. Select, for example, 1 or 2 or 3 or 5, or I don't know if it's the symmetry or no. I need to verify negative 1 and negative 5. Okay, this is the strategy. In red color to indicate the additional point gets the last step. Well, we continue then to say slang or horizontal. Es obvio que doing the analysis of the degree I did before, degree of the top is 1, degree of the bottom is 2. Therefore, when the degree of the polynomial at the bottom is bigger than, not necessarily 1, bigger than, si es 3, 1 or 4, 1, entonces that means que the polynomial in the denominator increasing faster than the polynomial in the numerator. Now this is horizontal asymptote, no slang anymore, no, horizontal. And this is a special horizontal at yz. So we have here, go. Dice, profe, we are writing down the word because I only see, oh, sorry. So I don't switch into the webboard. Oh, let me see. Oh, okay. Again, let me stop sharing and again switch into the webboard. Let me see. I can see. You can see. This is the problem, guys. Some computer, some internet connection is not the same. You have to don't frustrate. you see there are some delay, no? Whiteboard. Just in case, you let me know, no? I try to fix it. The fix is you stop sharing and again connecting with the same page. Do you see now? Do you see now or no?
Yes, I can see that.
Okay, super. Now we have, I try to explain that we have here the horizontal. It's not the horizontal aspect, sorry. Horizontal aspect. Add y cosine. This is vertical. Add x equal 4. And this is another vertical. Add x equal negative. Cool. Let me try to testing the symmetry of that function. Well, the symmetry is, you remember, you replace in the original function f of x, you replace x for negative x in order to verify the symmetry. And the symmetry is important because you detect the symmetry, you save time, because maybe the positive part and the negative part have some relationship, not completely crazy when it's neither. So you spend 2 seconds to test the symmetry. And the original. And either way, the f of x and the original was x over x squared minus 16. When you are doing the reflection, look, you replace x for negative x. And the top is minus x, but in the bottom, no, because the exponent is even. It says x squared minus 16. When you compare this expression and this expression, it's obvious it's the same expression but the opposite side. Because this negative, if you want, to see more clear, you write in the front. Okay. Therefore, this function is equivalent to this except case opposite side. So when you are doing this reflection, it's equivalent to make this another reflection. And this reflection, by the way, is different. This is a reflection about y-axis, and this is a reflection about x-axis. And they are perfect coincidence. When the situation happens, it's because the function is out. Good. Now, additional point, no, I don't want to waste the time with this. You go to decimals, in decimal you see the graph. This is question 4, no? Question 4. We try. Question 3, question 4. Now I know that I need to switch in the window to the decimal. No? Switch it to decimals. Okay, I have that. Boom. Do you see or no? No? Yes, I saw. Wow. Now I do that. Boom. Look at that. Look at that. Okay, let me explain in detail. I see several points. You see clear. That function is an odd function. Look. Suppose 3 comma negative something. Negative 3 comma the same but positive something, the same number. It's obvious it's odd function. Likewise, 5 comma something and negative 5 comma negative the same something, no? And we have 2 vertical and 4 in negative 4 and 1 horizontal and 0. Boom. I select the option D. Guys, today when I send the video in YouTube, I try to send to you this script. So the link, no? On the link, remember, you open and you see exactly my work. And this is a copy. You can fix it, edit. You can. It's a copy. You don't affect my work. Okay? Entonces, to select in the package, I select the option D, no? Check it, see I make a mistake, because sometimes I make a mistake. Cheeky. Look at that. Switching to the whiteboard. Let me see that in the whiteboard. Okay, let me see. Oof, esta page. Aquí solo. That page. Remember the vertical is in -4, +4, SD. For sure, SD. Cool? Everyone follow me? No problem, you understand? So far, 100 points, everyone? Cool. Let's move on to number 5. Okay, number 5, that page. Ow. Let me erase everything here. Okay, we focus on the page number 3 of package. Is f of x is equal x squared plus x minus 6 divided by x squared minus x minus 2. Okay, degree 2 and degree 2. Wow, yeah, I know very well when you have the same degree, you have horizontal aspect. Pero no now, this is in your moment you analyze it. But I don't know why I want to analyze that. That's what should I do? Well, the first step, always factor 4. Always. You factorization on the polynomial on the top. In this case, super easy because the trinomial is 2 parentheses x, 3 and 2, because 3 times 2 is 6. And somehow 3 minus 2 is 1. And the sign is positive 3 and negative 2. Good. And the bottom, similar. 2 parentheses. X is 2 and 1. Is 2 and 1. But opposite sign again, negative 2 and positive. Cool. In this example, yes, I detected that one factor is cancelled out. So immediately I know that we have a whole at x equal to. Okay, but now the original function is this. I want to copy again. Look, it's x squared plus x minus 6 over x squared minus x minus 2 is equal x plus 3 divided by x plus 1. Okay, that part and that part after the cancellation, x minus 2, and one detail. This expression is easier. We can use it always, but except n2. Because n2 is undefined. In this case, n2 is not undefined. It's the only difference. 99% of the time, we can use in this expression. The only restriction is n2. Because I know very well n2 we have one. And on that part, I don't know why some students don't understand very well. Do you understand? Yes. Cool. Now, what should I do? Well, okay. Y intercept, as always. Y intercept is evaluate the function and 0. But you using, what do you use in the original or the new one? Well, we use them both if you want, but I prefer the new one, it's easier than this. And you can do in any value except in 2, that's the bad guy. But in 0, no, in 0 is 0 plus 3. Divided by 0 plus 1 is 3. And the point is the point, 0, 3. This is the y. Cool. Now, add x intercept. X intercept is when the function is equal to 0. Likewise, I take the new one, pero this is equivalent to say P of x. Now PS x plus 3 equal to 0. X is minus 3, and the point is the point minus 3, 0. And you say, some students say, well, professor, wait. Because in the original, we have to factor on the top, que es x plus 3, they give me negative 3, nice. And the other is x minus 2, but remember, in 2 we have a whole. So I have no sense to take that and to enforce it to be 0, because actually in 2 is a whole is equivalent to say undefined. Entonces we have only one, x in a second is negative 3, 0. Okay, nice. Horizontal asymptote. Horizontal, no, vertical. Following the order. Vertical asymptote is vertical asymptote is cube x equal to 0. And cube x in our problem is x plus 1. Is at x equal negative 1. At x equal negative 1, we have okay, I do the partition to understand a little bit the function. And this is 0. This is negative 1, and negative 1 we have asymptote, vertical. I have no idea horizontal, but it's not important now for the partition. And in 3. A ver. In negative 3, sorry. Negative 1, negative 2, and negative 3, we have 1 x in itself. Entonces, in order to select the point I want to evaluate, additional point, maybe you select negative 2 is good, negative 4 is good, and maybe 0 is good, or 1, or 3, or 4. And remember, we have a whole in 2. 1 and 2, we have a whole, and the whole is represented like that. I don't know exactly how it looks like, but it's represented like that. Cool. Now, now the horizontal asymptote is the degree analysis. And we studied in detail at the beginning the degree is 2. So the same degree, yes, we have horizontal. No slang. Slang we have when the degree of the numerator is greater than 1 degree of the denominator. Otherwise, no. We have 2 examples of the horizontal when the degree is the same. Or, like in the previous example, in which the degree of the denominator is bigger. Than 1, but than 2, and 3 is bigger, just bigger. Now, in this case, the same degree, yes, we have horizontal. At what value? At y equal the coefficient is 1 here, and 1 equal 1. Just in case, it's very convenient. Check it out if the function crosses or not the horizontal. I don't know, I have no idea. But let's try. You take the function, the original function, get this, and you enforce it to be equal this, sorry. And you enforce it to be equal 1. You apply cross multiply. Now, it's obvious that our part is cancelled. And stay alive. Let me see. X plus x means this x equal minus 2 plus 6 x 2x equal 4 divided by 2, x equal to, oh, I try to do my best, however, I get the contradiction, because I know that at x equal to 2, we have a whole. It have no sense. Hypothetically, maybe the horizontal y equal 1 passing through that point, but actually in the original, no. I suppose we have something like that. I don't know exactly. C and decimals. Passing through, let me see, 0 here. Asymptotically to the -1. Negative 1. Negative 1. Negative 1. Vertical asymptote. Yeah, negative 1. Look at that. This is negative 1 if this. And negative 2 if this. Okay. Well, this is question 5. I want to see in decimals. Put together everything in decimals. Let me share a screen. Let me know if you see decimal or not. You see or not? Yes. Okay, good. Look at that. This is my perfect job. Look. We have, this is the given function. Look here. Look. We have the simplification function. After we can see, we have, for example, here. We have the vertical asymptote here. We have the horizontal. Okay, and we have addition. 4, something. Obviously, I skip the symmetry part, but it's all good enough. It's all good enough. There's no symmetry. Now you see the hole. Look at that. The hole is here. This is extremely important. So you are doing the graph of the original. This is the original, and the new one after the simplification. You see it's identical. Look at it. Look. Let me put together. Except that the original have a hole here, and after the simplification we have none. Okay. So the purple color is equal. The black color, except in the hole. Okay, the black color have no hole, and the purple color, yes, have hole. Clear? And when you select, and when you select the option, is the option D, I guess so. Let me see on the whiteboard. Option D. Option D. Let me see. Oh, it's the page 4. Let me try to find page 4 in the package. Really, where is? Disappear. I don't found. Okay, no problem. I erase everything. Yeah, unlock again the package. Okay, the package here in document. Okay, review for the MAC1140 critical group class. There you go. Select everything and put in the whiteboard. Okay. What page? Page 4, no? In this page. Let me make it zoom. Wow. Look at that. It's the option D. Look at that. It's the option D. That one. You see? How are you detecting this? For several reasons. Reason number 1, the hole. Look at the hole here, enter. But not only that, we have vertical in -1, We have horizontal positive 1, and the intersect here in negative 3, comma 0. There are several reasons. I don't care, because in the test we have no multiple choice. In the test you have only questions. You answer the question and show me your work in detail. One extra piece of it. Clear? Okay. No problema. Let's move on to 6 and 7, que es super easy. Is the inequality. Polynomial inequality. Polynomial inequality. Let's do number 6. Number 6 is x to the 4th power less than 9 x to the 2nd. And remember, don't forget, for solving this kind of inequality, the right-hand side must be 0. You move 9 to the left. Now factorization. GCF is x squared. X squared minus 9. I finish? No. I have to complete the factorization. Difference of a square. 3, plus or minus. Boom, I did that. And this is our new expression. Okay, by the way, it's equivalent to this horrible. Can nobody understand? This is super important detail. Super important. But we have more simplification. Do you remember that we have partial delete? Oh, partial delete. Or totally delete idea. Totally delete. This idea is when you have some factor like this can contain even exponent. Because in this case, you totally delete or partial delete. What do you think? Opinion. I want to hear opinion. Totally or partial? Totally or partial? Totally or partial? Totally or partial? You need to remember something. You need to remember when the inequality contain inequality contain equal sign like that, or like that. Oh, in this case, less than. Case totally delete. When the inequality have no equal sign, it's partial. But this expression is equivalent 100% to do this. X plus 3 times x minus 3 less than 0, and x is not 0. Because in 0 we have a whole. Partial delete. Es la idea. Si es equal sign here, totally delete. Y I copy this without that. Pero no, in this case it's partial delete. And you put and x no 0. Okay, so this is the, I know this is not important. It's important, but it's not the important part to solving this. We focusing now in this part. So in that part we have two critical value, no? X plus 3 equals 0, negative 3. And x minus 3 equals 0 is positive. And we do the partition. Infinity, negative infinity. 0, 1, 2, 3. 1, 2, 3. Negative. Professor, I put the partition at 0. Maybe yes, maybe no. It's up to you. Let's put the partition. The partition is I know that we have a whole. So now selection testing. The testing you select maybe negative 4, or negative 5, or negative whatever. Negative 1 or negative 2. And maybe here negative positive 1 and positive. Okay. Did I plug it in the original or doing the table? Either way. Doing the table, highlight. We do point in the first column, the testing point, get -4, -1, +1, and +4. In the other column, we put the factors, pero the factors can have important thing, que es x plus 3 and x minus 3, and no 0. Because I know default in 0 we have a 4. So plug it in. This is -4, gets negative, is negative, positive. And -1 is positive. Because -1 plus 3 is positive too. -1 and -3 is -4, that is negative. And 1 is positive again. And 1 is 1 minus 3 is negative too, negative. And 4 is 7. And 1 positive. Okay, I come back to the original. It's less than. To be less than is equivalent to say okay, negative. And the true negative is this and this. This is negative true. And this is negative true. The rest is false, completely outside the solution. Now I highlight. Is this interval. Wait, this interval and this interval. But we have no equal sign in our original equality. No. Therefore, when this situation happens, the polynomial, the endpoint is not included inside the solution. Entonces, paréntesis, and paréntesis. Be careful, remember, in 0 we have a hole. Therefore, this interval is extending to the 0, to the left and to the right, but not including 0. That's what the final answer. The final answer is paréntesis -3, 0, union 0, boom, que is the option B. Look at that. Option B. Super cool. No problema. Sofía.
Yeah.
Okay. Who are you, Mr.? You say, yeah. You are Mr. Cooper.
Yes.
Hey. Hello, how you doing?
Doing pretty good myself.
What do you think about this class? Is easy than the trigonometry or it's hard?
Well, the trigonometry actually helped me with this. It's pretty familiar. So although it's not the same identities, the trigonometry, it prepared me for this.
Okay.
It's a little bit challenging, but you explained very well.
Well, I try to do my best, but you are good student. Sometimes I explain another class in the same way, and the student, I don't understand. Well, okay. So we are good team. I try to do my best, and you try to do your best, and together we are the best. In Miami-Dade College. Okay, one more, and that's it.
Also, Professor, just one thing, Professor. Also, just like last semester, the YouTube videos, they help.
Yeah, no. Every semester, I using this. So immediately when the class is over, I send more than this. I send the video plus the link to connect it with Desmos. So in your computer, you can open the same Desmos that I created for this class, and you see clear, and you change that, and you understand a little bit more clear how you manipulate Desmos. Okay, this is part of the game. Part of the game is that you master Desmos, because I don't know, see another teacher using Desmos, another teacher don't using Desmos. The majority of teachers nowadays using Desmos or another software. Another polynomial, guys, the last one, I promise. Too much for one day. Well, factorization. O sea, right hand side is 0. I appreciate so much this help. Now factorization. Let's trinomial. Open two parentheses. Square root this guy is x squared. And the combination 121 is 25 and 4. Because 25 times 4 is 100. And somehow 25 minus 4 is 21. Don't frustrate if you don't see the combination. Because actually, if you want, you put like a quadratic equation, you apply the quadratic formula, and you get the same answer. Pero bueno, okay, I see the combination, entonces I use this. Okay, better for me. This is minus and it's plus. Okay, that's it. I feel no. I continue because I can see here clear a difference of a square. Oh, no. Wow. I can see this a difference of a square. Look, this expression is a difference of a square. So I continue factorization. Open two parentheses. This x and square root 25 5 plus or minus. And unfortunately, we cannot do anything here because it's not different of the square. It's a sum of the square. And you know again, the real field is not factorizable. It's factorizable in the complex field. Is, but a complex field I don't want here. Is x and the square root the negative 4 is 2i plus or minus. Pero no, in this part no. In this part no factorization in the complex field, and you leave like that because you understand very well that this is irreducible quadratic expression. Bang. And this is my equivalent inequality of this original, que es a little bit confused. Now, again, you apply the fantastic idea of the partial delete or totally delete. Yeah, I realize that this factor always is possible. But this factor never touches 0. So it's important that you see the differences between this parabola and this parabola. For example, this parabola is something like that. Now the vertex is here at 0,4 because actually the transformation plus 4 outside represents the vertical shift. However, this is a horizontal shift. In this case, 1, 2, 3, 4 is like that. This vertex is located at the point 4,0. Therefore, in this case, I need to take care to create a hole here, because this parabola at least in one point is 0. And so you suppose que 0 here. 0 times something is 0. And 0 greater than 0 is a contradiction. That is a reason that you partial delete. But in this case, no. In this case, totally delete. Because this guy is always positive. Look at that. And just this is equivalent 100% to say x plus 5, x minus 5, greater than 0. Yeah, I totally delete it. Okay? So there are not too much, but there are some reasons in which you need to analyze carefully si es or partial delete or totally delete. Okay, entonces now we focus 100% in this inequality and in the story. The critical values are -5, +5. It's obvious, right? And you are doing the partition of the real number, and we have no hole. In this example, no hole. Infinity, -0. 0, I like to put because 0 is the reference. No? That's the positive part, negative part. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Partition. Entonces you select maybe -6 or -7. Maybe 0 is super good testing. Well, I love you see the 0 is easy to evaluate. And positive 6. Good. Now I create the table. Table have first column get testing point. In this example we have only 3. And the factor involved in my problem is x plus 5 and x minus 5. The other time gets completely useless. Okay, you, for example, try to create one factor like that. No, why no? Because this column is always positive. This look at the parabola, it always is positive for all numbers you plug in. Therefore, do not apport information. That is the reason that I delete. And to say with the total. Okay, plug in -6 plus 5 is negative. -6 and -5 is -11. And 2 negative positive. Cool. 0 is positive. And negative and negative. 6 is positive, is 11. And 6 minus 5, 1, positive. It's positive. And we come back. At the beginning is greater than 0. And greater than 0 is equivalent to say to be positive. And positive is true here and true here. Therefore, the solution is our inequality lie in this region. So the testing point, no, que pass the test is 6 and -6. That part and that part. And what about the endpoint 5 and -5? Belong or no? No. Because our problem include only a strict inequality and no equation. A no equal sign is a clue que give me information that the endpoint do not belong to the solution. And it's obvious, no? So you plug in 5 here. 5 minus 5 is 0. 0 times any number is 0. And 0 is not greater than 0. And so you include the possibility to be greater than or equal to say yes. But in this case, no? What the final answer? The final answer is from negative infinity, comma -5. Remember, classical mistake of the student is some students believe that the interval ending in the testing point. No, testing point is arbitrary, guys. Okay, select here. But my interval is from negative infinity to -5. Union 5, comma infinity. Get the option D here in our handout. Cool. Okay, then we have one more or no? One more. The last one. I promise the last one because it's too easy. We are doing in 5 seconds. Cool. Sergio Medina dice cool. Okay, Sergio, I promise number 8 is the last one. Okay, we have time Wednesday to finish the review. I will send the reading test, and remember the reading test and the online test is due May 30, que is next Monday, and by the way, is holiday. Is what is the name of the holiday, guy? Memorial, no? Memorial Day, yeah, Memorial Day. So we have no school. So you enjoy the holiday. No, you enjoy doing the test, right? Oh, no, you can do that Thursday, Friday, Saturday, Sunday, and Monday you take a break. Okay, so now number 8 is easy. It's using the factor theorem to determine this. Okay, one polynomial is given. Look at number 8. Is f of x is equal to x cubed plus 2x squared minus 6x plus 8. Because I need to investigate semicolon, si the factor x plus 4 belong or not to this polynomial. So now you are doing synthetic division, maybe, why not? You copy inside the box the polynomial, and that way, 1, 2, -6, and 8. And you copy the divisor, but opposite sign, -4. This is important detail. Okay, because actual, this is a factor I need to prove. But the 0 is x equal -4. So it is -4, it's the -4 que I put here. And you bring down 1. And multiply. It's -4. Entonces es -2. Because +2 and -4 subtraction. And -2 and now multiplication is +8. And now we combine later again, it's +2, sorry. 8 minus 6 is 2. And 2 times -4 is -8. Wow. And this part is the remainder gets 0. But according to the zero factor theorem, when you perform the synthetic division and you get 0 here, it's because the factor x plus 4 belongs to the polynomial. I don't know the rest. I don't care the rest. The answer of this question is yes. You prove mathematically that the factor x plus 4 belongs to this polynomial. End the story. End the story. End the story. End the story. Okay, guys. So now we stop. No more. Too much for one day. Let me stop sharing. Stop sharing.
Professor. You're having issues, so I couldn't log in, but I'm here. We're using.
She was me. We're together in class. When you take attendance, just to make sure you have her.
Super together, no problema.
Okay, I'll send my email with the name to make sure I attended. Thank you.
Okay. Bye. Have a nice day, everyone.
Bye.
Have a good day, Professor.